Yesterday, NLP gave AI the ability to read and understand language, but there was a weakness. It processed words one at a time and lost context over long passages. Then, in 2017, one research paper changed everything. Today, we meet large language models, the technology behind ChatGPT, Gemini, and Claude. And I am going to explain exactly how they work in a way that will make you feel like you understand something most adults around you do not.
So how in the world did we go from those clunky old translation apps to an AI that can literally write poetry? Well, it all kicked off with one single game-changing idea that came from a team of researchers over at Google. This is it. This was the paper. And it's not just a cool title, it was the actual breakthrough. It introduced a totally new way of building AI, something called the transformer. And it was designed to solve the biggest headache in language AI, the problem of context. Okay. Let's really get into this. Before 2017, you have to imagine AI models reading a sentence one word at a time. Seriously, the big problem with that? By the time they got to the end of a long sentence, let alone a whole paragraph, they'd pretty much forgotten how it all started. Okay, take a look at the sentence. If I ask you, what was too tired? You know the answer instantly, right? It's the animal. Obvious. But for an old AI, this was a nightmare. The word it is so far away from the word animal, the AI would just get stuck. Was it the street? It had no idea. So the transformer brought this new superpower to the table called the attention mechanism. Now, instead of reading word by word, the AI could look at the entire sentence all at once. It can actually weigh how important every single word is to every other word. And boom, just like that, the problem is solved. With attention, the model can draw this super strong direct line from it all the way back to animal, totally ignoring street. It finally understood what the sentence was actually about. This was the key. This unlocked everything. Okay, so this new architecture was clearly a beast. It was incredibly powerful. But how do you train it to become something as smart as ChatGPT? Well, the answer, it's so simple it's almost going to sound like a joke. What's the fundamental task? What is the one simple game that gives these models the power to explain quantum physics, to write code, to do everything they do?
That's it. I'm not kidding. That is the entire secret. The whole training for these unbelievably complex models comes down to playing one simple game, over and over and over again. Just guess the next word.
Here's how it works. The model gets a piece of text with the last word missing, and its only job is to predict what goes in the blank. So if it sees the capital of India is, it has to learn that the right answer is New Delhi. To do that, it has to learn about geography. If it sees Virat Kohli is a famous Indian, it needs to learn about sports and famous people to guess cricketer. Now imagine doing this hundreds of billions of times with basically the whole internet. The model doesn't just memorize facts, it starts to build this incredible, complex map of how literally everything in the world connects.
Right, so a really simple game, but played on a scale that is just impossible to imagine. And that brings us to the L in LLM, large. Let's look at how that massive scale leads directly to the tools like ChatGPT that we're all using.
So when we talk about how big a model is, we're talking about its parameters. The easiest way to think about them is like little knobs inside the AI's brain. Every time it makes a guess and gets it right or wrong, it adjusts these millions and billions of knobs to get better next time. The more knobs you have, the more complicated and subtle the patterns you can learn. And the growth in scale here is absolutely staggering. You know, the early models we were playing with had maybe a few million parameters. Then suddenly GPT-3 comes along. That's the model that powered the first version of ChatGPT, and it has 175 billion. Today's models like GPT-4, they're estimated to have over 1 trillion parameters. This is the whole point. This explosion in size is what leads to what researchers call emergent abilities, these complex reasoning skills that nobody ever programmed in. They just appear once the model gets big enough. It's wild. So how did OpenAI get from this giant raw model to the product we know? First, they took their massive base model, GPT-3. Then, they did something truly clever. They used a technique called reinforcement learning from human feedback, or RLHF. It's a fancy term for a simple idea. They had real people rate the AI's answers. Thumbs up for a good one, thumbs down for a bad one. They basically taught it to be more helpful, more correct, and safer, based on what humans prefer. Then they just wrapped this fine-tuned model in a simple, easy-to-use chat box, and that was ChatGPT.
And the result? It was an explosion. ChatGPT hit 100 million active users in just 2 months after it launched. For a little while there, it was the fastest-growing app in the history of the internet. It completely changed how the world thought about what AI could do, almost overnight.
Now, this global revolution is amazing to watch. But you know what's even more exciting? It's not just happening somewhere else. This incredible technology is being built right here, in India, for India.
That's right. Teams all across our country are building our very own large language models. You've got BharatGPT, a collaboration with IIT Bombay. You've got Krutram from the founder of Ola. And you've got companies like Sarvam AI, which is focusing on the incredibly important task of understanding the amazing diversity of all of our Indian languages. So remember this. India is not just a consumer of AI. We are becoming a builder of AI.
So there you have it. Now you know how ChatGPT actually works.
But here is the question nobody asks. Where did all that training data come from? Hundreds of billions of words, where? And what happens when that data has problems? Tomorrow in Episode 7, we explore training data, the invisible fuel that powers all of AI. And it might make you think differently about the internet. See you then.